Hello friends. So here we take one special case problem. Okay, so where in the previous one we have taken a pentagon pyramid. So here we go with the one hexagon pyramid. Okay, so an hexagon pyramid, 25 mm sides of base, 50 mm axis length, rests on HP on one of its slant edges. So this is a very important one. Okay, so slant edge. So draw the projection of the pyramid when axis appears to be. This is a key, one more key word in this problem. Okay, appears to be inclined at 45 degree to the VP. Okay, so as already I have shown in the introduction part also. Okay, so this is what is the slant edge is. Okay, so it is going to rest on the one of its slant edge. Okay, so this will be on the floor or on the ground. Okay, so when it should be on this slant edge in the second position, means the first position should be resting on the corner. Okay, so here we have one hexagon pyramid. Okay, so 25 mm and 50 mm. Okay, rests on HP. So now it should be on a corner because it is resting on the slanted. So second position, it is on the slanted, and third one, very important, axis appears to be. Okay, so appears to be means it's a no locus line, so no need of finding any beta line here. Okay, so it is inclined at a 45 degree to the VP. Okay, so very important, appears to be and a slant edge. Those two are the keywords. So slant edge is nothing but it is resting on the corner, because they are not going to specify that one. It is going to rest on a corner, because by looking at the slant edge you need to find assume like it is resting on the corner. Okay, and the axis is appears to be inclined. Appears to be inclined means so there is no a locus line in that finding beta angle and all. Okay, so to start with that one, so we're going to have, okay, so VP and HP. Okay, so we know how to construct an hexagon, okay, which is going to rest on the corner. So corner means so the side is 25 mm, so you can just take a 25 mm radius, just drop one circle. Okay, so this is the center. So on the corner means corner, whenever we are going to have a corner, so then you have to take a horizontal line. Then from here you just cut the arcs from ends. Okay, so when this one is done, you can just okay, so as this is a pyramid, so from the corner to the center each line will be dark. That is the main thing you have to do. Okay, so this is how exactly. So this is O in the bracket O1, so we'll write from here A, B, C, D, E and F. Okay, so when this one is done, just do the dimensions here. This is closed arrow, so 25 mm. Okay, so when this one is done, so to have a projection from each corners, here. Okay, so we'll write this is A dash, so this is FB, so F dash in the bracket B dash, so this is O1, so we'll write O1 dash, so this is E dash in the bracket C dash, and this is a T dash. So when this one is done, just darken the line and from the center it's a 50 mm. Okay, so when this one is done, you can just drop the boundary, then from each corner you will see a dark line. Okay, so this is how exactly it is visible. So now to do the naming, that is the dimension, you just drop it here and you say this is a 50. Okay, so now it is the slant edge is resting, so no inclination on that one. The slant edge here is O to A, that is O dash to A dash. So this should be on the XY line. So you have to take a O to A dash and taking any reference on the point that is A dash, you just cut on the XY line. Okay, so this is our O dash. Okay, so A to O, taking any reference on that one, just cut a arc. Okay, so when this one is done, here the slant edge will remain same. So from O you just cut one arc, and from A to D just take a one more arc. Now complete this. Okay, so this is our D dash. So now take the reference from each point, cut one arc from here and one from the D, then from the midpoint. Now join 1, 2, and the center is a axis line. Okay, so this is A dash, F dash, B dash, O1 dash, so E dash, C dash, and D dash. So now to drop the projection, rightmost and the bottommost. Okay, so O is here, so we'll write O. So next we have a D. So D is here, we'll write a D. We'll take a F and E and C. So this is C, so this is E. We'll take this is O1, this is P and F, this is a E. Okay, so now once we see from here, it is like a looking like this. Okay, so now in here you can see all the face. Okay, so now without any second thought, the whole hexagon face is visible. So A to B, then F, then C, then to the D, then to the C. Okay, so now O to D is visible. So O to D is a dark line. Okay, so now from here to here this will be boundary. Okay, so from here to here it will be the boundary. Okay, so when this one is done, so we have a line O to A. So O to A till O to D it is a dark line. So here it's a dotted line, only this much. Actually it should be A to O should be dotted line, but already it is overlapping with the dark line, so we'll make a dotted line from A to D. Okay, so now again from O to D it's a dotted, and from F to O also it's a dotted. Okay, so now measure O to O1. It is around 45. Just say this is a 45. Okay, so this one is done. So now it appears to be okay. So appears to be means it's a no locus line. It is at a 45 degree. Take any one point and say this is a 45 degree and just drop a line. Okay, so now say for example we'll take a reference point here as a O. Okay, so this is 45 degree. Okay, so we'll take the directly second axis line, that is appears to be okay, O to O1. So from the reference point we'll cut an arc. Okay, so now directly this is our O1. So this is O, this is the O1. So by taking these two you have to replicate this hexagon here. Okay, so now so we have O1 on the same line, we have a D, we have a A. Okay, you just measure from O to A1 how much it is. It is coming around 11. So from O1 you just measure 11 on the same point. Okay, so these are A. Okay, so we have O to D, so we take from O to D. From O we just mark it. So this is our D. So now we got O, D, O1, A. O, D, O1, A. Okay, so now again from D, so from A we will measure how much this one is. This 22. Okay, so here also it is a 22. Okay, so we'll keeping a line here, a perpendicular line. We'll take a 22 this side and 22 this side. Okay, so now we got these two ends, here and here. Okay, so now we'll measure from here to here. Okay, so now directly we'll measure from here to here. It's a 24. Okay, so now from each end just drop a line at 24. Here also 24. So now you just see it passes through the D, then it is proper. Okay, so if you want you can just drop a thin line also. So now we got this one. So now from each end say take the opposite one and cut. Say here one line, here one line. So here one line and here one line, because all these remains equal. So now just take a, so the whole base is visible. So A, so we have taken like this. So this is will be B, C, D, E and F. Okay, so from C rest and all dotted lines. Okay, so this is how exactly we can reconstruct the pyramid. Okay, so when this one is done, so now to take the projection, so we'll be having the uppermost and the rightmost. Okay, so then we'll take a all vertical. Okay, so last is a O is on the XY line, so O dash. Right, so now, so this is D, so where is D? So D is here, so this is our D dash. So E and C is on this line, so E is still here, so you can say this is E dash. So where is C? C is here, so this is O1, so this is O1 dash. So next F and B, so we'll take a longer scale. So this is F dash and here's a B dash, and A is on the XY line, so A is on the XY line. Okay, so now we have A, B and a C, okay, and D, E, F, O1. Okay, so when you see from here, you can see all base here. Okay, so we'll connect A to B, B to C, okay, C to D, D to E, and E to F, and again F to A. Okay, so when this one is done, so now from O, okay, so if you keep a scale, so O to C will be the boundary, okay, and O to A will be the boundary. Okay, so when we stand here, so B is nearby, so through the B it is visible to you, like this. So when this one is done, so we have all these dark lines, so below whichever the lines are going here will be dotted line. 1, 2, and 3. Okay, so the last one is a axis line till here. Okay, so this is how exactly it is visible. Okay, so make sure that see, once you are viewing from here, the base will be visible, so base will be visible, whatever the base here is a hexagon, so hexagon is visible. Then darken the boundary. Okay, then you stand here and see, so you can see B, C, A, so A, B, C, the line passing through that one to the O will be visible. So once you draw that one, so as we already know, once line is dark, so whatever the lines which are going below that one will be dotted. Okay, so no two dark line will cross each other, so this will be, you apply this rule, so then things will be easy for you people. Okay, so this is how exactly we can solve a pyramid resting on the slanted, that is the corner. Okay, so then the axis appears to be, axis appears to be. Okay, so thank you.